Okay, so let's start with SNAP for the Oil India Limited. Subject क्या रहेंगे आपके?
So power systems.
Power system. What is load flow?
So asking a definition. Okay, sir. Load flow analysis or load flow studies is known as the power flow analysis. Is an essential method to examine what are the problems that are going on with the power systems network or grid. Load flow analysis is used to determine the state of the equipments present in the power system network in order to ensure that the power system operates in within the specified limits. And it is also used for load flow analysis is also used for substation, also for substation development also.
Okay. What is the basic difference between load flow and power flow?
So load flow analysis is mainly used for determining the state of the various power system equipments in the network, where power flow is the actual flow of active power, means active power that is flowing from one from sending end to the receiving end of a transmission line.
Okay, how many type of buses are there generally?
Well, there are load bus, PV bus, and slack bus. Yeah, so load bus also known as the PQ bus, where known components are PQ, and we have to find out the unknown component is V delta. Delta is the load angle, and V is the terminal voltage. And PV bus, as the name suggests, known components are power and voltage, PV, and unknown components are Q and delta, that is the reactive power and the load angle. And the slack bus is the known components is V delta, that is the voltage and load angle, and unknown components is PQ.
Okay, what are the method of determining the load flow?
Well, there are many methods. The most fastest as well as the less iterative method is a Newton-Raphson method, but also there is Gauss-Seidel iteration also. Also there is a method of least convergence method also. Newton-Raphson method is actually the best.
Okay. Is the load flow in the load flow equation, it is the linear one or the non-linear one?
So load flow equation is linear or non-linear?
Yeah.
Sir, load flow equation is actually a non-linear equation, sir.
Okay. In the method of determining the load flow, Newton-Raphson, Gauss-Seidel, fast decouple. In this method, is there any linear one or all the method are non-linear one?
Sir, actually, any load flow solution, calculation of load flow is actually a solution in a set of nonlinear equations. So, simultaneous nonlinear equations. So any, so nonlinear methods, sir, or nonlinear algebraic method actually.
Nonlinear algebraic method. Okay. What is the basic difference between the Newton-Raphson and Gauss-Seidel method?
The basic difference is Newton-Raphson method is actually the error is very less than Gauss-Seidel method, because more number of iterations and less time per iteration. And Gauss-Seidel method will have less number of iterations and more time per iteration. And Gauss-Seidel method has a component called the converging component of alpha, but Newton-Raphson method does not have that type of converging component. And the number of equations that the memory requirement for the Newton-Raphson method is much lesser than any of non-Gauss-Seidel equations. And the number of equations also required for Newton-Raphson is the number of equations that is required is actually less.
Can you write down the load flow equation?
Load flow equation.
Hmm.
Okay, sir. I will write down copy and show it. And
Okay, no, just give me the basic one. How it is even
yeah,
written.
sure. Okay, okay. So the load flow equation actually is actually means load flow equation is actually you want the whole it means
Mm-hmm. Okay. When we study the steady state stability, what does it mean?
so steady state stability is actually the phenomena by which the power system, entire system, its initial state after small disturbance that has occurred on the system. That is the steady state stability.
Steady state stability. Okay.
Yes.
What is the mathematical notation of the steady state stability?
Sir, the mathematical notation of steady state stability is actually state stability is P is equals to V by X sine delta.
Mm-hmm.
Where E is the total amount of EMF and V is the voltage and X is the reactance and delta is the load angle sine delta. And the maximum state stability occurs at delta 90°. V
If
by X.
suppose, if suppose the fault has occurred in the system, so does it affect the stability?
What does occur in system? Does it?
Mm-hmm.
So, to repeat the question once.
If the fault has occurred in the system, in the transmission line, so does it affect the stability of the system?
Fault is occurrence. Yes, sir. Because the fault has occurred in a particular transmission system, it will affect the stability. The system will become unstable. But after some time, if it returns back to its initial point condition, then it becomes a steady state stable point.
Mm-hmm. So which type of stability will affect? Net stability or steady state stability?
So after post fault, actually after a large amount of disturbance, and that's basically transient stability takes place when after a large amount of disturbance has takes place. That is a large amount of fault. Large fault has a severe fault has occurred, and after that, if the system becomes unstable, and after that, if the system returns back to its original position after a heavy fault, then it becomes transient stability.
Because surge has occurred in the system, right? Because surge has occurred in the system, right?
Surges, yes.
So does it affect the voltage or the load angle calculation in the load flow?
Surges affecting loading effect. I mean, does it affect the loading effect?
Yeah.
Yeah. If the surges are occurring in the system, then using the load flow, power flow, load flow studies, then yes, sir, it affects the load flow, sir, because a high amount of current will be bypassed to the ground during surge using surge absorbers.
Okay, last question.
Yes.
If I talk about the transient stability and the steady state stability, which stability is more and why?
More
In the quantity wise. Limit, transient stability limit and a steady state stability.
which quantity wise more. Sir, transient stability is more.
And why?
Sir, because sir, after sorry. Steady state stability will be more because in case of steady state stability, what happens is that a system can never operate up after means after a fault occurs when the system comes to the initial conditions, that is a steady state condition, right? So steady state conditions means the system is stable now. So it will not be so there is no state after the steady state condition. That is the maximum limit. And transient state, what happens just after the fault has occurred. So that is that stability at that time is not transient stability. So after transient stability comes steady stability. So steady stability will be greater than transient stability.
Okay, listen, Akash.
Yes.
Okay, the basic part of the pulse term has been completed. So from tomorrow we should discuss about the in-depth concept of the pulse term. Right.
Yeah.
See, the power system is interrelated with the machine and the stability in the control system. So we will cover the basic of that. And in the industry purpose, they will mostly asking about the type of the switches, type of the circuit breaker, type of the transformer, right?
Yes.
Okay, and for the snap of today, it is fine. Okay.
Yes.
Mm.
Sir, all the answers are right.
Yeah, all the answers are right. Some questions, some answers are up to the limit, but although yeah, in the PSU interview, like warranty limited, they will not go into the depth of the concept. They only cover the basic one. Okay.
Okay. Thank you. Yes.